Hi, everybody. My name is Gary Rylander from Iron Mountain, and with me today is my colleague Steve Matthews from Active Navigation. We're going to talk about a challenge that I think you're all familiar with. It's the challenge of classifying information, and it's really the ultimate information governance challenge. Whether you're talking about managing retention rules, privacy rules, information security, you can't really apply a policy to a digital object until you know what that object is. So that's why it's the ultimate challenge.
Thanks, Gary, and hello, everyone, and thank you for attending this session. Before we get started, quick disclaimer. I'm just going to read this out, that the opinions discussed today are those of the individual, myself or Gary, and do not represent the firm that they may be affiliated with, nor are they necessarily customers of Active Navigation and or Iron Mountain. I'm Steve Matthews, VP of Enterprise Sales at Active Navigation. I've been with the company in the US for around about 10 years now, and my background is very much from technical pre-sales all the way through to the business development, working with some of our largest customers such as Equifax and Voya Financial.
And I'm Managing Director of Global Consulting at Iron Mountain. And I've spent much of the past 15 years, 20 years dealing with the challenges of records management, information governance, and classification. I'll have been with Iron Mountain 5 years in June. Before that, I was a partner at IBM Global Services for many years, and like Steve, I have a strong background in artificial intelligence, machine learning, and classification technologies. So I'm sure everybody who's listening today is aware of the fact that most of you have retention schedules in place. You've had them for a long time. By the way, I forgot to mention, if you want to type questions into the chat box at the end of the presentation, Steve and I will address them. But even though you all have retention schedules, the odds are that for most of you, most of your content is actually redundant, obsolete, or trivial. In a well-known study done back in 2012, it was found that approximately 70% of the content in most enterprise information architectures is rot, and probably 5 to 10% for records, maybe 15% if you're a financial services institution. And everything that the CGOC found in their survey in 2012 reflects what Steve and I see on a day in, day out basis working with our customers. So that's the situation we're in. How did we get here, and what can we actually do about it? It's not for lack of trying. We know everybody's been trying. In fact, generally we know that everybody is out there trying to use artificial intelligence and machine learning to solve a raft of business issues, yet most projects fail. And it's also probably true that most people who are looking at automated classification solutions have had difficulties getting here. So we're going to talk today about what these challenges are to information classification and how we improve the situation. Back in 2014, and this is just one of many studies, AIM did a study where 43% of the respondents said that they felt the only way to keep up with the torrent of information that we're seeing today is to automate the classification of it. And in the most recent Cohasset survey that Iron Mountain was one of the sponsors of, about 15% of the respondents said that they fully automated the classification and management of email, but only about 5% have been able to automate other more complex types of unstructured information, such as files on shared drives and SharePoint. So what are these challenges of classification? There are really five of them. One is the number of categories that you need to classify into, what you do when those categories overlap, the challenge of coming up with an appropriate training set and its size of that set, the availability of those training sets, and the availability of subject matter experts to help you identify those training sets. If you'll notice, looking at these, this sounds like machine learning, and that is our primary frame of reference today, though one of the reasons that Iron Mountain and Active Navigation have teamed up to address this challenge together is that Active Navigation offers another way to do that. Steve, you want to speak to that?
Absolutely, Gary. Thanks for that. Yeah, so our approach is very, very different from the traditional machine learning. As we're going to see and as we're going to discuss during this session, is that we're all about trying to minimize disruption to the business, to the users, and minimize how much effort has to go in to being able to identify the relevant content and classify it accordingly. Machine learning, as we'll see, can be complex and very time consuming. We're trying to be as pragmatic as possible and reduce the time frames and the level of efforts that are required.
So here again, let's look at some recent survey information, again from Cohasset. The 2019 survey shows that 74% of you have at least 100 to 500 plus categories of records. I had one client who had 2,400, and only 26% have fewer than 50 categories. Why is this significant? Because traditionally in data science, we look at each category, or facet as some people call it, as its own little separate mini engineering project. The algorithms need to be trained for each of those categories. So if you have 10 categories, you have 10 little mini projects. If you have 500 categories, you have 500 little mini projects that you need to address as part of this.
Absolutely. Just to add to that is one of the key challenges we see with training sets as part of machine learning is that you have to know exactly where the right answers are before you can even consider training. And as Gary's pointed out, with 74% of organizations having at least 100 plus categories, that's an awful lot of definitive data that you have to know where it exists. And then most things in life and certainly in business are evolving all the time. So once you've trained those categories, that's not the end of it. You've got to maintain them and recognize and train the system and the software on new patterns that are emerging over time. So it can be a very, very time-consuming activity and leads to what the data scientists might call as drift.
So the next challenge is each one of those little categories requires training material. How large should that training set be? Well, the training set size increases with the number of categories. Data scientists and statisticians usually start with something called the 10x rule of thumb. Sometimes it could be 5x, sometimes it could be 20x, but usually they start at 10x. If you have 100 record classes, you need 100,000 exemplars, and that's a lot of example documents to round up.
And again, to reiterate the point, it is a very significant amount of relevant documents that you have to find. And the challenge that we're seeing that most organizations face is, in an ideal world, you'd know everything about your data and where it exists. That's not the reality of the situation. And before you can even begin to think of undertaking a machine learning training exercise, you really have to be able to understand your data. And this is really where organizations are struggling today. There has been so much data created over the years, and historically, like the Wild West, people able to create or save almost anything anywhere in the organization. No one truly has a handle on what data exists or where. Commonly, even for mid-size organizations, we're finding hundreds and hundreds of terabytes of data that we have to sift through in order to help better understand what data truly exists rather than what they believe should exist. And it's a major challenge for organizations today.
That challenge is further exacerbated by the nature of the categories that you're classifying into. If you have categories that overlap that are non-optimized, it's going to look like the blob of data on the right. And in order to be successful with classification, whether it's human beings or algorithms or rules, you ideally want to establish categories that are discrete, separate. There's even a data science way of measuring that called K-means. So let me give you an example. 15 or so years ago, Stanford University and IBM Research did a project comparing machine learning to the way human editors at Yahoo, yes, that's still when Yahoo was manually classifying and editing content, and they looked at their categories and they found that where categories were naturally discrete, like food and music, there was no problem classifying them. Where they had categories like computers and internet, which, believe it or not, back then were separate categories, they constantly overlapped, and neither human editors nor algorithms could clearly distinguish between them.
This all, again, comes back to better understanding your data within the organization. Once you can understand what data you truly have, it means that that drives how you might look at categorizing and organizing data against policies and processes. Because as Gary's been describing, if you end up with these unoptimized categories on the right, there's a lot of review that has to happen. So a single document, for example, could fall within 3 or 4 different categories. If that's the case, then the reality is a human being typically will have to make a decision about what is the best home for that piece of content. The more that we know about the data, the more understanding and logic behind what is out there means that we can refine the rules to become more like the left-hand side, more optimized. And where there's less overlap of saying this file could fit in these 3 different categories, that means that there's less of a manual review process required in order to approve the results that the engine is coming out with.
So where do we get all of these documents from, all of these exemplars? Well, usually it's some sort of subject matter expert. And all of them have day jobs, which don't include records management or content classification. And even though since usually the object in these exercises is mostly to classify this content against a retention schedule, the subject matter experts may know quite a bit about the subject, but they may not know anything about the retention schedule or understand some of the more data science-centric challenges we've been describing. And if you go and ask them for 100,000 examples stretching across 100 categories of documents, they're going to object to that. Steve, you want to talk about some of your experiences there?
Very much mirrors that, Gary. What we have found is a lot of these information and data classification programs have come to a grinding halt because the disruption to the business is immense, and users are users. And if you ask them to do too much, they are going to push back because they have a day job to do as well. So allied to the previous comments about being able to understand what data really exists in the organization, being able to identify, as Gary alluded to earlier, the ROT, the redundant, obsolete, and trivial, taking that data and making it out of scope means that we can focus our time and attention on the data that really matters to the business. And by being able to understand that better means that we can look at ways of minimizing the disruption to those individual end users, so they're only making decisions on the blurred or the items where we're not completely clear on where they should reside in the classification scheme. And that's so, so important. You need the users on board, and any of these programs are not just about a technology solution, it's a 3-legged stool. people, process, and technology are all intertwined. And if you take away one leg of that stool, the stool's going to fall over. So really important to manage those competing priorities.
The next challenge is the challenge of getting access to the data that you need. Most organizations are not going to permit their intellectual property, their data, to be used as training sets for anybody else. That's understandable in many ways. But the result of that is, particularly if we're talking about machine learning, that vendors will walk in the door with completely untrained algorithms. In fact, if you think about it, one of the most used algorithms for natural language processing, like classification of documents, is what's called naive Bayes. And Bayesian algorithms are termed naive because they need to be trained. So you start out with untrained, naive algorithms, and then you need to train them from scratch because of the nature of machine learning and the nature of people, not surprisingly, keeping their data close to the vest. That's the case with machine learning. It's a little bit different when you're using other technologies.
Yeah, and again, this is going to sound like a broken record, but it's so true. Being able to carry out what we might term as a blind discovery of the data. What do I mean by that? Well, I mean that you don't have to tell the system what to look for. You don't have to give it all the answers, know all the answers before you start. By being able to point at the data, and our linguistic algorithms and our technology is able to extract the real meaning and context of what that content is truly about, rather than what we believe or the organization believes it should be about, really provides additional context. And that really helps drive the information and data classification process, because we're exposing what the key information is in order in such a way that the business and the organization that can then really take control of that data and that information and look at ways of categorizing it in a way that reflect the content as well as the business requirements. We quite often find the two things are not compatible, i.e. the business requirements are carried out independent of the data, and then when it's put in front of the users, the two things don't marry together. And that's where problems really start to occur. So how do we do this? Well, we have a defined methodology. And so Active Navigation has developed this over a number of years with well over 150 clients. Some global in nature with multiple petabytes of data, down to clients with 4 or 5 terabytes of data. The first thing is, there's a lot of information on this slide, but our process really boils down to the first step on any project is to carry out that discovery, build out a data map of what content truly exists, where it exists. And as part of that process, we provide out-of-the-box rules for elements such as simple policy rules to identify out-of-date content, temporary files, backup files, the like. We also supply a raft of privacy rules complying with GDPR and CCPA type regulations. As part of that initial inventory, that data map of content, we're able to identify that potential rot content. We typically tend to find 30 to 40% of content in that first pass is characterized as rot and being out of scope for the ongoing data classification process, which means that we can then apply our intelligence and our smarts to the content that's remaining. And this is where we use what we term as calculated fields, which are basically metadata rules that will extract from within the content the key pieces of information. So that could be elements such as social security numbers, credit card numbers, other PII, PHI data. And that then enables us to expose where that at-risk data resides and identify and help the organization understand what they need to do with it next. What I would say is, in our experiences with clients across the board, and particularly within the financial services space, what we tend to find are hotspots of areas where sensitive data may exist. And what this allows us to do is to identify effectively broken policies and broken processes within the organization. So as part of the data classification process, as Gary's going to describe in the upcoming slides, is you want to focus on the data that really matters, not everything. And the more that we can identify from this rotten sensitive data that's indicating broken processes and policies, means that it's reducing the size of that haystack, so that when we get into the true smarts in terms of the data and information classification, we're doing it only on the data that matters.
So Iron Mountain looked at this methodology and this tool, and there are two ways to come up with your extraction rules. You can go do a series of workshops with all the various functional areas of the company and quiz them about what kinds of documents they have, and look at their retention schedule and so forth, and sort of manually build it. But we think there's a better way to do that, and we tried it, and it works. And that is, we can either import a retention schedule from Iron Mountain's Policy Center solution as a rule set into Active Navigation, if you have an Iron Mountain Policy Center retention schedule, or we can actually take one of our templated set of classification taxonomies, which are the first part of the retention schedule, against which we apply retention rules. And we have standard templates for general business entities as well as particular industries. And we found that we can, in fact, easily, quickly export from Policy Center and import into Active Navigation and really begin classification almost at once. So this slide is a spreadsheet download of a set of standard classification categories from an Iron Mountain retention schedule. And the left-hand column is really the functional breakdown, so audit and compliance, corporate governance and administration are major functional areas within the organization. The subclassification is really another way of calling it the record classes, which is what they are. And then there are the string of record examples, and the three parts together constitute a taxonomy. So we can first classify from Policy Center into Active Navigation what those functional areas are. There are usually a dozen to 2 dozen at most functional areas in most retention schedules, and then add in the record classes, which hopefully are less than 100, but we can deal with however many there are. Certainly there are less than 100 in our traditional standard templates. And finally, we add in all of the record examples. So what we've done here basically is we've created this bag of words, if you will, that is built into a set of rules, and we've defined a whole slew of keywords here and phrases that we are looking for within the actual content itself. And once a standard retention schedule is imported into Active Navigation, this one is our general business entity classification rule set. It turns into 105 rules in Active Navigation. And like everybody else who does natural language processing, our usual first test data set is Enron email, because everybody has access to it. It's public information. So we first ran this against the Enron email set, and lo and behold, what did we find? We found, just as we would expect, remember we're expecting 5 to 10% of the content in an organization to be records, and that's exactly what we found here. So this histogram depicts that the greatest value is no value, which is another way of saying it didn't classify into any of the record classes. If you look at this in a tabular format, you can see that of the total of 517,000 files in Enron, approximately 487,000 didn't meet any of the categories, and the categories that it met were, I think, about a dozen or so on the top rows, and that just about exactly what we were looking for, 29,000 or 5.7%, classified against the retention schedule. And this is not just what we found against dummy data. What you're looking at right here is an actual engagement that Active Navigation and Iron Mountain did together against live data using, in this case, this customer's own retention rules. And what we found was that about 78% of what was classified was really redundant, obsolete, or trivial. About 16% were documents which were less than 2 years old but potentially classified against the retention schedule, but they are what records managers would call transitory documents. And a lot of organizations don't require documents to be declared as records or non-records for a year or two after they've been created. So that those still remain to be seen, whether they're rot or whether they're records. And finally, we found about 5% to be actual classified into the record classes and over 2 years old.
So this is in line with what we see in the majority of customers. And again, this comes back to data has been collected over the years. And a common refrain that we hear is, we need to keep everything just in case. Well, that opens the organization up to an inordinate amount of risk, because everything that you keep becomes discoverable. And certainly if it's containing sensitive information, that increases the risk in the event of a data breach. And so much data has been created with people having no idea of what really is out there. We find a lot of duplication where people make a copy of something that someone has sent them, then they forget where that copy is, they download it from the email, save it somewhere else, and this gets repeated ad infinitum. And so essentially there is a much smaller pool of data that is really relevant to the organization than most organizations would really consider. And so not all data is created equal. And as part of this process, we are finding that 70% plus can be identified as out of scope from a data or information classification purpose.
So I don't want you to come away from this thinking that we are bad-mouthing machine learning. Machine learning is one of the amazing technologies of the ages and will continue to be, and provides great value. But there is some real value in looking at using semantic rules, the type of thing that Active Navigation uses to classify content. And it's not an either-or proposition. In fact, one of the advantages of what we've been talking about is that it enables you to have the best of both worlds. So when we began to do this work together, I began to wonder if other people had arrived at some of the same conclusions that we had, that there was real value in first going after a large corpus of information using a set of keywords and phrases and semantic rules that are finely configured. And I found a number of results. One of them from last fall was in the BMC Medical Informatics and Decision Making Journal, where the authors, who are academics in this space, wrote an article called "A Clinical Text Classification Paradigm Using Weak Supervision and Deep Representation." And what they mean by weak supervision is basically just what we've been talking about here, a rules-based natural language processing system. And they say that the way you create these rules is either to do workshops, get experts to provide the input into those rules, or use a knowledge base. In our case, the knowledge base is an Iron Mountain retention schedule, and build out those set of rules. And that's exactly what they did. And they ran those rules against some raw clinical data using 3 different use cases for that clinical data. And as a result of that, they were able to tag that raw data with labels based upon its classification, by the rules. And then they took the clinical data that was now improved, if you will, with those labels, and they fed it against 4 different machine learning algorithms, and then ran those machine learning algorithms against also unseen clinical data. And here are the results of the 3 use cases. And I know this is a bit of an eye chart, but stay with me for a minute. The first use case, using rules-based natural language processing, they got an F1 score of 91. What's an F1 score? It is the harmonic mean of precision and recall. And this is the standard way that data science looks at and calculates the accuracy of classification. And they then took, and remember this score of 91 was a result of 0 training. It was a bunch of rules applied against the data and then tagged it. And then they took that now improved data set and they used it to train 4 different types of machine learning algorithm: support vector machine, random forest, MLPNN, which is a type of neural network, and convolutional neural net, which is probably the most advanced kind of deep neural net, deep learning set of algorithms. And ultimately, when they finished the training for the first use case, CNN was able to slightly outperform just pure rules with an F1 score of 92. But in the end, even with the training documents, SVM, RF, and MLPNN all ended up with lower F1 scores than good old-fashioned rules-based natural language processing. The second use case, similar. Out of the box with no training, rules-based scored an F1 score of 93, which was about the same as some of the machine learning algorithms, and ultimately convolutional neural net edged it out a bit. And the third case is really interesting, because in the third use case, none of the fancy, modern, sexy machine learning algorithms were able to compete with a well-constructed set of semantic rules. It gets even more interesting when you look at the accuracy measured against the size of the training data that's required to get it that accurate. Remember, no training is required for natural language processing, so that blue line is straight all the way across from 1,000 documents in the training set out to 20,000 because it didn't need any training. But if you look at the use case on the left, ultimately the convolutional neural network algorithm matches the precision and recall of just the plain old rules, but it took almost 10,000 documents in the training set to get it there. The use case on the right, no, there it was surpassed, natural language processing was surpassed by support vector machine almost out of the box with 1,000 training documents. And ultimately, random forest caught up with it, as did convolutional neural net, which ultimately surpassed it. So the point of all of this is that both types of technologies can work together very, very well. Certainly, rules-based classification is much faster. It requires not only less time, it typically requires less computing resource. It requires no training, really. It requires a good set of rules and then some validation of those rules before you begin processing. And it requires considerably less subject matter support than does machine learning. And I would argue that using an Iron Mountain records retention taxonomy is the baseline, increases the precision of those rules-based record classification tasks. And one of the reasons is, our retention schedules are basically crowdsourced. Iron Mountain has been doing retention schedules for more than 20 years. Our retention schedule has hundreds and hundreds and hundreds of current users. So those record classes and the examples we provide and the functional areas they fit into is the result of what basically 500 peer companies or so have said about this is what our standard retention schedule looks like. So that, for us, that seems to be a great way to jumpstart all of this by beginning with a pre-tagged Iron Mountain retention schedule. And finally, I'm happy to announce today that through an arrangement between Iron Mountain and Active Navigation, you can actually license a records retention taxonomy from Iron Mountain, or if Iron Mountain is not working on your project with Active Navigation, then you can license it directly from Active Navigation.
Yeah, again, this all comes back to classification of data is only good as the data you're passing to the classification engine. And going all the way back to the beginning, by uncovering what information you really have rather than what you believe you have, that is the first key foundation piece, because that then means that all of these processes that Gary has been describing are going to become far more effective. A couple of points around projects of this nature is we see an awful lot of reluctance from organizations to hit that big delete key. Oh, I'm not sure what the ramifications are going to be if I delete this data. And so using the software, we're able to quarantine data that is deemed out of scope. So it's a halfway house. It's not deleted, but you're not diluting the effect of the useful data. And then if you store that in a quarantine location the users don't have access to, if they don't squawk for that data back in a certain period of time, maybe we can then look at archiving or purging that data. So there's all manner of policies and processes that can be applied to these programs to make them most effective. So we believe that we are best of breed in what we do for dealing with this legacy data, with the vast amounts of content that have been stored out there for the years. We have the pragmatic solution that's being built from the ground up to solve the business problems that you all have today. When I say pragmatic, it's not about giving the perfect answers across the board. It's about giving enough information that the business can make rapid, informed decisions on what to do with the content. It's highly scalable. Our biggest client, Equifax, we've deployed across many different countries, many different data centers, sometimes within the same country. So this really works at a very large scale. Organizations are able to rapidly understand what content really exists, be able to apply processes and policies and lessons learned, best practices from the field very quickly, so that you no longer are you paralyzed by inertia. By being able to drive you to the key nuggets of the information means that you can make rapid, informed decisions on what to do with that content. And really, it matters not where it exists. It could exist on a file share. It could exist in Unix. It could be on a SharePoint repository. Whether it's on-premise or in the cloud, we can collate the results of those disparate data sources and report against it as though we're one single data source in order that those rapid, informed decisions can be made.
And I'm sure most of you know who Iron Mountain is. We're probably storing your boxes, but we're a lot more than that. Speaking from the perspective of our professional services team, of which I'm a member, we are the largest IG consultancy on the planet. We have more than 200 people in that practice, and we're a Noah's Ark of skills, from certified records managers through more lawyers in a small law firm, industry subject matter experts, and library and data scientists. And we're happy to help you anywhere from the development of strategy all the way through to day-to-day operations and to deal with your information retention, privacy, and digital transformation needs. And, you know, we are really an agnostic consultancy. There are about 5 different products that we've used and do use for content classification. So when an agnostic firm like that looks at an Active Navigation and says, wow, this is really an effective and efficient tool to use, believe us, we benchmarked it against all the others, and what we've said here today is very much true. So we finished our presentation, and we've hopefully left a little time to answer your questions. Let's see what they are.